we want to solve this common problem by using four important ideas. Idea 1, idea 2, idea 3, idea 4, Allam's theorem, and idea 5, AMGM. Okay, these two problems are same problem 5 of CJMO 2023 and problem 3 of CMO 2023. We want to consider ideas that are useful also in CMO CJMO 2024. General ideas in geometry. These two problems are same like USAMO and USJMO. Some problems are same. Okay, let's solve them. Okay, it says an acute triangle is a triangle that has all angles less than 90. 90 is a right angle. Uh, it is because it is acute, then we know all altitudes are inside the triangle. This is let ABC be an acute triangle with altitudes AD, BE, and CF meeting at H. So this point is H. The circle passing through points D, E, F. Okay. It says passing through points D, E, F meets AD these things at X, Y, Z respectively. So ADX, this point, BEY, BEY, and CFZ. Prove the following inequality. AH over DX plus BH over EY plus CH over FZ greater than equal 3. Before solving this, I should tell you some ideas. Then after that, we can solve this problem. Okay, first idea is what? If we draw angle bisector, internal angle bisector of A and external angle bisectors of B and C, you should know that they intersect at IA, eccenter of A. If you don't know this, or if you had any question, feel free to send message my WhatsApp number. Okay, now we want to prove what? TB is equal to TC is equal to TI is equal to TIA. This idea is so much useful. For example, it was useful in AIME 2024. Exam for USA after AMC. Also in USAMO 2023, it was useful. So the reason is what? First, we can say TB is equal to TC. Why? Because it is angle bisector, so it is A over 2, A over 2. This arc is A, inscribed angle, this arc is A. So these two arcs are equal, so corresponding chords also are equal. So TB is equal to TC. Now I want to prove it is equal to also TI. By angle chasing, I can easily prove this. Because BI is angle bisector of B, it is B over 2 this one, B over 2 this one is equal. It is this arc, this one, A over 2. This angle is exterior angle of this triangle, A over 2, B over 2, A over 2 plus B over 2. And as you can see, this angle is equal to this angle. Both of them are A over 2 plus B over 2. So TB is equal to TI. We proved this. The only thing that is left is equal to TIA. Internal angle bisector and external angle bisector are perpendicular to each other because this plus this is 180, half of this plus half of this is 9. So this one is also 90 degrees, so this quadrilateral is cyclic, okay? So because we proved TB is equal to TITC, T will be circumcenter of BIC. But because we know BICIA cyclic, so T is circumcenter of that and TIA equal. Also, you can use angle chasing. You can say this one is C over 2 because it is cyclic. This one is also C over 2. It is 90 degree B over 2, A over 2 plus C over 2, 90. So C over 2, C over 2. So it is idea 1 that we proved. So we proved this one. Idea 2. We want to work on angle chasings when we have let me tell you, when we have altitudes. So first we can say, okay, because it is 90, it is 90. Two 90s see the same side, same side BC. So It is we have four main rules for proving a quadrilateral is cyclic. One of them is this. So we can say BFEC is cyclic. Okay. Now, because it is cyclic, we know it is C, it is 180 minus C because this one plus this one is 180. So this angle is C. Okay. In cyclic quadrilateral, always we can say this angle is equal to this angle because sum of opposite angles equal to 180. So we can say this angle plus this angle is 180, this angle plus this angle is 180. So these two things are equal. We can say this angle is C. Similarly, we can say this angle is B. Now for this one again, we can say similarly this one is cyclic. So this one is equal to this one B, and then this one C, A. Okay. Now this angle is what? Because it is 90 minus A. So this one is 90 minus A. Similarly, this one 90 minus A. This one 90 minus B, 90 minus C. And let me write this other color. 90 minus C, 90 minus. So we use these angle chasing now. I want to for idea 3. We want to consider, we call this triangle DEF orthic triangle. We want to see lines, for example, altitudes of ABC corresponds to what in DEF? Altitudes of ABC are what are these three lines, AD, BE, CF. Okay, so we can say what? We can say these altitudes are what in triangle DEF? Internal angle bisectors. Because as you can see, 90 minus A, 90 minus A. So that's right. Internal angle bisectors. In PMO also, we had a problem in PMO Philippine Mathematical Olympiad that you should, in that problem, you should consider this orthic triangle. Also in IMO, we had problems with this idea. Now here CMO and USAMO in AIME 2024, we should work on these ideas. Altitudes, now you can say orthocenter. Orthocenter is intersection of altitudes is what in center because intersection of internal angle bisector. Now sides of ABC are what? Because look, it is internal angle bisector and sides of ABC is perpendicular to internal angle bisectors of DEF. So what is perpendicular to internal angle bisectors? External angle bisectors. Okay. External angle bisectors. And last one, vertices of ABC. ABC are what? As you can see, for example, this one. Internal angle bisector, external angle bisector. We said sides are external angle bisectors. So there are concurrent at X center. So it will be X centers. Okay. Idea 3 and one idea is left. Ptolemy's theorem says what? It says AB times CD plus AD times BC is equal to AC times BD, and it is equal if and only if ABCD is cyclic quadrilateral. Okay, we call it Ptolemy's theorem. Okay, we prove these things, and let me tell you also one idea in algebra, idea 5 that we want to use. It says what? It says x1, x2, 2x, and AMGM inequality. If xi are positive real numbers over n, arithmetic mean is greater than equal geometric mean. We call it AMGM inequality. Nth root of x1, x2 to xn. Okay. Now we are ready to solve this problem. Okay, for solving this problem at first, I want to prove AX is equal to XH, XF, XE. How can we prove this? If you pay attention, here we prove this TI, TB, TC, and TIA when we draw internal angle bisector. If you consider triangle DEF, okay, if you consider triangle DEF, let me draw this triangle DEF. Let me draw DEF. We can say what? We can say this line is internal angle bisector. We proved. We're in idea 3 and idea 2. It is internal angle bisector, okay? And it is circumcircle of DEF. And if we combine this with idea 1, we can say AX is equal to XH because H is in center by idea 4. H is in center of DEF. AX is XH and A is X center of DEF. Like this. IA, we proved here these parts. So we can say AX is equal to XH is equal to HF is equal to HE. If you had question, as I said before, feel free to send message to my WhatsApp number in the description. Okay. So we know AX is equal to XH. Now, here I can say AH is what? 2AX. 2AX. We want to prove this. Over DX plus BH is what? 2BY over EY plus CH is what? 2CH over FZ, 2CZ over what? Over FZ is greater than equal 3. We want to prove this. Now, I said AX is equal to XH, HF, HE. Let's consider this one. For example, this value, it is related to A. I can say it is equal to, for example, XA. Okay. Next one, we can call it, or let's call this one X. Okay. This one, we call it Y, 2Y. So this one, we call this one AX. This one Y, this one Z. So if we divide both sides by 2, x over dx plus y over ey plus z over fz, y it is greater than equal 3 over 2. Okay, now let's see what can we say about x. It is x, xh is x, all of them are x. If we use Ptolemy's theorem in x, e, d, f, it is cyclic. If we use Ptolemy's theorem, we can say what? X, it is x, we said. Let me draw these lines with green. XE, which is x, times df. So x times df plus xf, which is x times de. X times de. It is equal to what? EF times dx. EF times dx. So we can say x times df plus d is equal to EF times dx. We want to find x over dx. So if we divide both sides by dx and then divide also by this one, it will be EF over df plus de. Okay? Now we can say, okay, x over dx is this. So similarly, we can say what? It is EF over df plus de plus this side of orthic triangle over sum of these two sides. Next one, y over ey. Y is related to what? Is this one. So it will be df over ef plus de. Similarly, plus z over fz is de over ef plus df. We should prove why it is greater than equal 3 over 2. Okay, now we want to prove some of these three fractions is greater than equal 3 over 2. We can define this one as r, this one as s, this one as t. So it will be what? R over s plus t plus s over r plus t plus t over r plus s. Why it is greater than equal 3 over 2. There are lots of ways to prove this. One way is to multiply both sides by these denominators to get rid of them. So it is equivalent Got r times r plus t, r plus s, similar terms, times 2, because of these two, is greater than equal 3 times s plus t times r plus t times r plus s. Okay? Now, we can say left-hand side is what? We have 2r cubed here. Similarly, we have 2s cubed, 2t cubed, plus 2r squared s r squared t. R squared s plus r squared t, then, for example, s squared r s squared t, and plus t squared r. We can write like this, dot, 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 to have more space. Then RTS, 2RTS, 2RTS again, 2RTS, so 6RST, greater than equal. Here, when we multiply, it will be 3, again, r squared s plus r squared t, and so on, like this one, plus 2 times RST, why SR, here STR, and TRS, only 2. RST times 3, 6 RST. So we can cancel these two terms here. These two things are same. This part and this part here. We have 3 of that here, 2 of that. So if you simplify, we take these to right hand side. So we have 1 from that. R squared s plus r squared t, and so on. Y less than or equal. We want to prove this. We want to prove this equivalent. Again, equivalent to this one, 2r cubed plus s cubed plus t cubed. Now let's write all terms. S squared r plus s squared t plus t squared r plus t squared s. Okay? Now for proving this, we should use AMGM, idea 5. Okay? For AMGM, we can say what? R cubed plus s cubed over 3 for this one is greater than equal cube root of r to the 6 s cubed, which is r squared s. Okay? So we've applied this one. Then for next one, r cubed plus t cubed over 3 is greater than equal r squared t. And for next one, s cubed plus s cubed plus r cubed over 3 is greater than equal what? Is greater than equal s squared r. So this one. And if we write like this, if we add all these terms, obviously right hand side will be this, left hand side will be what? For this one, we have 2r cubed over 3. 2r cubed over 3. So let's find coefficient of r cubed. 2/3 plus 2/3. For this one, 1/3. For this one, 1/3. 1/3 plus 1/3. And also for s cubed, t cubed, we have same thing. 2 cubed plus 2 cubed, 2, 2, 4, 5, 6. 6 over 3 is 2, exactly 2r cubed that we had. Okay, so we proved this inequality by applying all these inequalities, and this one is okay, now this one. So we proved the problem. If you want to learn other important ideas in geometry, it has also another solution. If you want to learn important ideas, Euler's line and important lines, theorems, formulas, 40, 50 important formulas, each topic, combinatorics, algebra, number theory, and geometry, feel free to send a message. My WhatsApp number in the description and comments.